Hello and welcome to our Wednesday webinar from the International Centre for Sustainable Carbon. My name is Benedicta and I'm part of the communications team here. Our monthly webinars are based on our technical reports, which are available from our website, sustainable-carbon.org. Residents of member countries and employees of sponsoring organizations can download our reports at no charge after a one-off registration on the website. Please type any questions you may have in the questions box as we go along, and we'll answer them at the end of the webinar. The subject for today's webinar is Emission Control for Coal in India and Indonesia, a reality check, presented by Professor Lesley Sloss. Over to you, Lesley.
Thank you, Benedicte. And just a reminder, as Benedicte says, please put the questions in the question box as you go, and I'll be sure to try and answer them at the end. Now, as Benedicte says, these webinars are usually a presentation of a report we're about to publish. However, this is more of a summary of reports we've published over the last 4 years on a project that we've carried out in India and Indonesia. And over and above that, it's a comment on the lessons I've learned during that time, especially due to the pretty much 5 months I spent on site in the country. So I'll summarise the project aims, look at what we achieved, and why this may vary from what we initially set out to achieve. Over the last few years, I've given several webinars and presentations. These are available one-click download from the outreach page of the website, including the reports and all of the presentations we gave at all of the workshops. Everything I talk about today should be on that website. So as I say, I want to take a step back and have a look at what we aim to do. First and foremost, of course, I must thank the US Department of State, who provided the generous grant to carry out this work. The overall aim was to assess the challenges in the coal industries in these growing economies in India and Indonesia, and to provide relevant training and capacity building to overcome the roadblocks and to accelerate the emission reduction. The focus was centred around mercury, but as we know, you cannot control mercury emissions from coal without controlling other pollutants and vice versa. So it was very much a multi-pollutant type approach to reducing emissions. And the goals and the project, the way it worked in these different countries was quite distinct. In India, we focused on technologies for the different issues that they had facing them over there, whereas in India, it was more about working towards a certain compliance strategy. So in India, we were looking at plant efficiency, making sure emissions were as low as they could be, emissions monitoring to comply with the new emission limits, emissions reduction to get down underneath those limits, and the handling of iron ash that's produced from the control technologies on the flue gases. So it was very technology orientated for India. In Indonesia, it was more about working with the ministries and the government under the Minamata Convention on Mercury. And that requires an inventory across the whole fleet, and then an assessment of that fleet to determine a compliance strategy that would work. And then ultimately, we were supposed to identify finance to support emission reduction projects. However, as I'll talk about at the very end, that was the biggest challenge for many reasons. So let's look at each of these in turn. India and flexibility. The problem, as we know, is that coal is designed as a baseload fuel. It can be flexed, but that's not what it was designed to do. And as we increase renewable energy on the grid, we are asking coal to flex more up and down. Now, in most economies in the Western world, they have gas available and they can flex gas easily. India does not have gas. Renewable energy is only available when the sun shines and the wind blows, and nobody has the battery capacity to make renewables dispatchable at the moment. So Indian coals must flex. And this means using less coal, running at lower temperatures, lower pressures, shifting operation weekly or even daily, or even twice a day in some cases. And this, of course, ramping up and down causes changes in temperature and pressure. Things break, they snap, they corrode, they leak, they burst, all sorts of issues. EPRI, my good friend Stephen Storm at EPRI, they have developed a flexibility toolkit, which is essentially a 10-sheet spreadsheet Excel workgroup that you work through putting in data on how your plant's operating are things as they should be, are the pipes fine, the temperature, how's this? You fill that all in and it will tell you at the end what to prioritise in terms of maintenance to ensure that breakdowns are avoided. And we provided training with this to over 500 delegates in India. And if you want that training, it is available, over 500 slides available on the website. You can download those or talk to Stephen. I'm sure he would be happy to give you a training course on site or remotely. However, even the best toolkit, and EPRI's does have the best toolkit, even the best toolkit cannot stop plant damage from multiple flexing. It can only act as an early warning system for the potential threats that are going to arise. So the reality is Indian coal plants must flex. In the rest of the world, they might need to flex depending on the grid. In India, it's a government requirement, and this is unique to India. Further, the amount of flexing Indian plants have to achieve is actually also specified. At the moment, they must achieve down to 55% load, and they're expected to push that down to 50, possibly by the end of this year. And as you can see in the graph in the middle there, this is how much the flexing has changed across the Indian fleet since 2008, significantly more flexing. And as we say, the temperature and conditions are not ideal. Damage happens, a lot of plants shutting down or not operating correctly. And when it comes to the emissions, which is what we're worried about, emissions will increase if efficiency comes down. And in the case of flexing with cold starts and so on, it can be 10 or even 12% increase emissions due to that efficiency drop. Over and above that, at the same time, many of these Indian plants are trying to install low NOx burners to bring down the emissions of NOx. The way low NOx burners work is with this stoichiometry, excuse my English, the balance of the coal feed in, the temperature, the oxygen, and so on. And during periods of flexing and startup and shutdown, low NOx burners do not work as they should. That's going to affect the emissions. And at the same time, in plants, when you're two-phasing and you're going down and changing temperatures a lot, you, in many situations, are going to have to bypass an FGD system simply because the fluid class temperature and pressure isn't right to feed it in there. It would cause more damage. And so, ironically, as we ask coal plants to flex more to improve the amount of non-fossil, more clean energy onto the grid, these plants themselves are becoming significantly more polluting as they do so. And that's obviously less than ideal. The report is there. You can scan that on the phone and download it on your phone or email it to yourself or go to the website and get it. It's summarised the issue and provides the link to the EPRI toolkit. At the end of this work, we could walk away, and have we achieved anything? I don't know. Flexing is such a high priority in India that we felt we couldn't just walk away. So we've created this working group, this legacy initiative called Flex India. It's an expert working group and it's currently led by Stephen Storm at EPRI, and it's hosted by the Confederation of Indian Industry. It's populated with experts from the Indian power companies and utilities, the regulators, the Electricity Association, relevant experts and technology providers, mainly based in India. It has been meeting online once a month since January this year, and they had their first face-to-face conference in September in Hyderabad. If you wish to be involved, just reach out to me, email me, and I'm sure we'd be more than happy to get you involved, perhaps with the monthly meetings or with the Flex India event that will happen at the end of next year. My wish list at the end of this part of the work is for exactly this, the continued collaboration between the utilities and the government. It's an issue that's going to take a lot of time and effort to resolve. Coal is the necessary bridge in India to renewable power. But as it provides that bridge, its own performance and its efficiency will decline, and so people will look even less favourably upon it. The government is going to have to take this into account, work with the utilities to hopefully not necessarily fund best flexing practice, but take into account the financial challenge these plants are facing during this period, and perhaps work in terms of tariffs and offsets to encourage plants to do their best with flexing and emission reduction at the same time. Moving on to emission monitoring, India had no emission limits prior to 2015 when they only had a PM, particulate matter emission limit. Since then, they set emission limits that were equivalent to those in North America and Europe. and they hope to have them applied within 2 to 3 years after that 2015 announcement. That's not happening because of the scale of the challenge there. And in order to ensure compliance with those plants, they have to put CEMS, continuous emission monitors, on all the units. And those plants have to report their data in real time to the regulator. Now, unlike Europe and North America, India has no existing infrastructure which can provide support to these emission monitoring systems. No installation services, no calibration standards, no auditing or even training. And so mistakes are being made, and we're seeing them being made. It would have been relatively simple to cut and paste either the methods from Europe to India or the methods to America, but India chose to adopt both approaches. And whilst this means that Indian sources can buy technologies and expertise from all of the Western world, it does mean that they have a combination of mismatch of techniques and standards and methods that have to be applied. So we took trainers from Europe and North America over to India. We provided training to over 600 delegates, and it was during this face-to-face discussions that it became clear that they felt somewhat abandoned in terms of training with these CEM systems. They are given introductory guidance from the vendor when the system is installed, but then they're pretty much left to their own devices, except for perhaps an annual visit from the vendor to check that everything's working. And that's a big ask because there are qualifications for CEM operation in Europe and America. There's nothing in India. So the reality check is that all plants have to have CEMS for NOx, SOx, particulates. And now in regions such as Bhopal, there's a call for mercury CEM systems as well. And data is in small on the right there, but it's also obviously easier to read in the report. You can see the installation for in the 3 rings there, particulate, SOx and NOx. The green shows plants that have them in these emission monitors in place, working correctly. The orange is we're not sure what's happened there, something's gone horribly wrong, and the yellow is where we know they've got CEMS, but they're just not reporting correctly. So obviously there's a big issue. Only 50% of the plants are consistently reporting the information correctly. And over above this, there's this bizarre challenge in India that all the data from the CEM systems must be sent to the regulator live and in real time. Now, in Europe and North America, data from monitors on any plant are processed into hourly, weekly, daily, monthly averages, and the plant or operator has the chance to sit down and note excursions. That's when the emission limit may be exceeded, and say, okay, we exceeded the limit there, we owe you some money in terms of a fine, or that wasn't an actual excursion, that was a plant ramping up and down, that was a calibration check, or something went wrong there. And so at the end of the month or the time period, the regulator gets a nice summary of where issues are being addressed and where problems remain. It makes it easy to keep on top of it. It does rely on a certain level of trust from the operator, but that can be built up over time. What's happening immediately now in India is that just literal swathes of information and data are being sent directly to the regulator, with exceedances and excursions flashing on a daily basis because the CEM systems aren't working correctly. And there's no way the regulators are qualified to go through that volume of data and work out what's actually going wrong. So something needs to change there. Too much data is as bad as no data at all. So the wish list there is going to be in terms of either going to the European or the US method of processing data before it's sent in. Otherwise, the regulators are going to have to set up some specialist department to work through this data, and that will be a costly challenge. So in terms of output from this sector, we have the CEM report on the top there. That was summarizing the challenge that I've just discussed. But also at the bottom there, Sanjeev Kanchan, who's our wonderful consultant in India, what he did was he took the current best practice guidance in India, which was produced by the Electricity Association there. It's a very short document. It basically says use the methods given to you by the Europe or the USA. What Sanjeev has done is combined everything, including the expertise from America and the US and Europe, into one single document so that people have one document they can go back to. Now it's being distributed hard copies and soft copies around India as much as we can. It's already been adopted by the cement sector as best practice, and we're hoping the utilities will do so too. We're not precious about it. If people want to change it and modify it to suit their own source category, we are more than happy for that to happen. We just want people to work together on best practice. To this end, we've created this legacy initiative that we've called SEM-EG India, this Continuous Emission Monitors Expert Group. It's hosted by the Council for Energy and the Environment and Waste, and it's still in its infancy. So they've only had 2 meetings so far. However, they plan to build up membership by collating information on who's doing stack testing and monitoring in India. They hope to have a launch in SEM India. That's a meeting that's happening in February in Delhi next year. Registration is open. You can exhibit there, and they're also the call for papers for SEM India closes at the end of this month. So if you're at all keen to come and present in India, run a training course, give demonstrations with your equipment, we would be more than happy to hear from you, and we guarantee you an engaged and enthusiastic audience when you get there. The wish list, of course, is for standardization and coordination of training in India. Pragmatic processing of that emission data that's not working at the moment. There needs to be a change to this real-time application of data before that's going to work. Emission control, as I said earlier, the emission norms have come in. They were introduced in 2015 out of the blue, and they hit hard. These are challenging emission limits equivalent to those in the Western world. India expected their utilities to be able to comply within 3 or 4 years, and of course that's not happened. It's a big country with a lot of challenges. They were expecting plants in India to achieve what Western world took 4 decades to achieve. Further, the Indian coals are 40 to 50% ash. An order of magnitude more ash than most internationally traded coals. So the technologies that work in the Western world won't necessarily be boltable onto an Indian plant and work immediately. So India is going to have to work through the commercial technologies available and work out by trial and error what is going to work in the Indian fleet. This is going to be costly and time consuming, especially for those plants that step up and do it first, because they're going to have to spend a lot of money investigating why things didn't work and how to fix them. Hopefully they will share that information to accelerate the rest of the fleet. We can sort of summarize this challenge. Sorry, here we go. This is what's happening in terms of sulfur emissions installation across the fleet. So control strategies, basically FGD for sulfur. We see around 6% of the fleet are already in compliance with respect. That could be FGDs. In some cases, it might be low sulfur fuel. The rest are either in a phase of tender awarded or floated or feasibility. Now that looks quite good, but that chart has been fairly consistent for several years now in that the plans are there, but the actual movement into practice is proving to be a challenge for several reasons. Firstly, these legislation came out in 2015 and derogations are continuing. So plant managers are hesitant to say, well, why should I move now? Derogations may continue and I can save myself some money for a little bit longer. There's also the challenge of if these, I don't know, 700, 800 units in India are all trying to put in control technologies at the same time, then there's going to be a shortage of expertise, of equipment, of base metals, whatever they need to build that kit. And of course, there's the financial challenge. In a time when many countries are talking about phasing down or phasing out coal, many of these plants are going to be asking themselves, am I going to get payback on my investment in the time period that my plant has left to run? And of course, at the same time, they're being asked to put biomass co-firing, they're being asked to flex. So the report is there and it summarizes these challenges. We've not created a legacy initiative on this, it's not our position to do so. It's too much of a challenge, it's too intrinsic to the utility sector. It needs to be addressed at the government and the utility level by talking to each other around a table, as it's a big problem. We did have one suggestion. Rather than expecting this sort of blanket compliance with FGD and DNOx across the fleet, we did a basic ranking of the plants, and here you can see, you can't see it, but if you download the report, you can go into it in detail. And it's not saying that these are the dirtiest plants by any means. What it's saying is these are possibly relatively young plants, relatively high capacity plants, the plants that we know will be relied on for decades more to come. So if you're going to want to achieve results quickly, if you focus on maybe the top 15 of these plants first, then you'll get a really good reduction in emissions that you know is going to last for decades across the grid, without wasting too much money on smaller, older plants. So tactical approach is what we're trying to talk about there. The final area of concern in India was the ash management. Now, India has a legal requirement for 100% utilisation of its ash across all coal plants. And this fresh ash must be delivered free, so at the plant's cost, to any end user within 300 kilometres of the plant. That's a lot of trucks travelling a lot of distances at the expense of the plant. And if they don't do that, they are fined for it. So looking at this map, that just sort of darker orange swathe across the middle there, that's where most of the coal is produced, where most of the power plants are, and of course where most of the ash is produced. And at the same time, it's also the area of the country which has more than enough fly ash. The end sector markets are already saturated. So there needs to be more saturated and joined up thinking about how to achieve 100% fly ash utilisation. Bearing in mind that it is now recently being expanded to legacy fly ash. So they must also use up these older, in many cases, wet underwater damp dams and ponds and piles of ash that are sitting around. Now, as I've mentioned several times already, Indian coals are between 40 and 50% ash. So they're essentially trying to burn ash in terms of rocks and stones. So a lot of ash comes out the other end, 230 megatons per year. At the moment, they're achieving around 60% utilisation of this fly ash. And unless something changes in terms of new markets and infrastructure, it's going to take them 20 years to get rid of all that legacy ash. And plants are now facing financial penalties for not using this ash. Add this to the penalties for exceeding emission limits, demands to flex and so on. You can see where the coal sector is beginning to implode in terms of financial compassion and the need for support there. The photos on the right are the real reality from my trips to India over the last 18 months. 12 different regions and 12 different workshops. On the top there is my favorite thing to do in the morning in India. You pick up the local newspaper, and almost every single newspaper that is close to a power plant will have some comment for the local community about how they're not happy with it. Either a fly ash issue is as shown here, or a pollution issue, or too many trucks in the road, something. And it shows that the population are becoming more aware of how coal-fired power plants are affecting them, and they're being held more and more accountable. In the middle there, that's me hanging out a car window, taking a picture of 19 trucks that were about to shift fly ash from this unnamed plant. Now, it had taken us several hours to drive to this plant. So you can imagine the state of the roads when you've got a continued amount of trucks with fly ash travelling up to 300 kilometres to get rid of this ash. It's an infrastructure problem that creates a whole new environmental problem in terms of road dust and road emissions. And on the bottom there is another common feature that you will see in remote roads in India. Potholes, I mean, they're common in every part of the world now, but they are particularly bad in India due to the monsoons and so on. And India is huge, and a lot of these areas are quite remote. And so the roads are pretty poor in terms of construction. And so you'll see a lot of situations where somebody has dumped the means and the methods and the materials to fix the potholes, but there's not been joined up thinking. Nobody's going out with a spade to actually do that. And a lot of these piles you can see are kind of wasting away, being washed away and adding to public mess and becoming homes for cows and all sorts. So potholes remain, and that's going to be an issue that could be resolved with wider thinking in terms of fly ash management and use. Now, again, there's the FLEA report. I've only brushed on what's in there. We do look more regional information, plant by plant information of who's producing ash, who's managing to get rid of it, who's not. We get good examples of companies that are building dedicated train lines, and dedicated hubs for moving fly ash further afield, and also plants that are putting in, I think it's an NTPC plant, for example, that's putting in an aggregate construction material on site. So they're creating their own aggregates, they're creating their own tiles and bricks. These are materials that they can sell direct from the plant rather than pay to give to an end user for the end users to sell. So recovering revenue and investment and so on. Also high-end products, especially for those big piles of legacy coal ash just sitting there. And this is something that South Africa is also looking at. The recovery of cenospheres, the little bubbles of fly ash that are really good as filler material, or rare earth elements. Big buzzword at the moment. Rare earth elements. Governments of countries are very excited to get as many of those as they can within their national availability, because they're good for defense systems, for computers, for high tech and so on. Having your own supply of rare earth makes you solid and dependable as a country. And so India is very keen to find its rare earth elements. However, there is no means by which any coal-fired power plant is going to invest money in paying for research for a legacy coal ash pile to find out if it happens to have some rare earth elements that are not yet created industry in India might want in the future. This is something that's going to have to come down from the top level. If the Indian government want rare earth element security within the country, then they need to set up some sort of coordinated stakeholder working group to look at what end uses they have for those, how to source them, and if necessary, go back to the coal piles and provide funding for them to be evaluated in terms of rare earth recovery. It's all in the report. Please do look at that. Final thoughts on India before I move on. India is trying, it really is. They've gone from little or no emission monitoring or emission control requirements before 2015 to something that's comparable with the Western economies. And this is a huge leap, and it's something that we shouldn't really be expecting them to do within the time period that they seem to have given themselves. Obviously, there's hiccups and problems. And international assistance must recognise that this is not going to work. They can't expect India to cut and paste what we've done and expect it to work with the challenges they have. And if we want them to accelerate their uptake of control technologies, you're going to have to give them some financial support. They cannot afford to be making all these changes and investments simultaneously. And I will talk about that at the end. That's what I'm going to close this talk on. Very quickly before I do that, I shall move on to Indonesia. As I said before, this is very different from the India study, in that we were working towards creating a compliance strategy under the Minamata Convention on Mercury, which requires the fleet to control and, where feasible, reduce their emissions. And that involves evaluating emissions from the fleet, ranking the plants, finding a cost-effective emission reduction strategy, proposing projects, and that report will be out by the end of this month, we hope, and then talking about funding. And another report will also be out on that, but no, not with the results that we were hoping to get there. So you've seen this before if you tuned in for our reports and my webinars. So I'll just a quick reminder, we calculated mercury emissions unit by unit across 111 units in the Indonesian coal fleet. And based on this, we worked out that there were 15 plants out of those 111, which over the whole lifetime of the fleet will emit almost 50% of the total emissions. So assuming these plants all continue to run as predicted, then by spending money on these top 15 rather than over 100 plants, you could reduce emissions significantly, very quickly and cost effectively. And then what works, and those plants can be cut and pasted over time across the remaining fleet. All that information on the you can get from the QR code download report. Now, the original plan was to, and still is to some extent, to choose 3 plants that were representative of the Indonesian fleet. What worked at those plants could be cut and pasted across. So we chose Python because it was interesting, because it has a seawater FGD system. We'll talk about that in a minute. We chose Suralaya because it's one of the biggest plants, currently 8 units. I think they're going up to 10 units. And so it's a nice plant that represents a lot of the fleet. And we chose Ombolin because it was the one plant named in the report as being the dirtiest. Genuinely the dirtiest, a mine plant that was emitting orders of magnitude more than mercury than the rest of the fleet per gigawatt hour, simply because it was an inefficient plant and therefore theoretically a quick fix, a quick cheap fix. And so obviously best laid plans don't always work out as you plan them. Some ways good, some ways bad. Since we named Omberlin as a plant that needed to be upgraded, it has been upgraded, which is great. A company has gone in, upgraded it significantly, and it's now running as it should be. We include that as a case study in the report that will be out at the end of the month. But at the same time, we also include details of other upgrade systems and approaches that could be used, because we were not allowed to obviously support one individual commercial supplier. Moving on to Suralaya, the plant we had identified, the unit we wanted to work on has been named under the Just Energy Transition as a plant that might be phased out early. So we're going along with a kind of generic Suralaya type plant to look at strategies. And Python, the seawater FGD, could be a liquid emission issue, and I'm just about to talk about that. Over and above that, we have to consider phase down plans and the new requirement for biomass or even ammonia co-firing in Indonesia. So the whole strategy for reducing emissions has to have a broader view than we originally thought. And the catalogue report does include all of that, and it will, as I say, be out at the end of the month. I'm going to quickly mention Python, as this is where I ask for help. We know the Python seawater FGD unit is capturing some mercury. Indonesian coals produce a lot of elemental mercury, so a lot of the mercury will be going straight out of the stack here, even in an FGD system. The obvious solution would be to oxidants, and that would increase the mercury coming down in the solution, which is great. However, from what we know of a seawater FGD, the mercury is not, as it would in a wet FGD system, going to end up in the gypsum where it's in a nice controlled situation where it's not going to be an environmental concern. In these systems, it's either being re-released during the aeration stage, which is not good, because that's at ground level mercury being released into the environment, or potentially even worse, it's being concentrated and then released into the local seawater, into the local water body, and that's where the fish is, and that's exactly where we don't want the mercury to be. It's not a unique challenge to Indonesia. We know there are seawater FGD plants in India, Thailand, Vietnam, potentially the Philippines, I think. A lot of Southeast Asian countries with a lot of seawater, a lot of coastline. It's cheaper to put in a seawater FGD system. Seawater FGD is great for sulfur. That's what they're putting them in for. Our concern is they're actually creating a potential new mercury issue. We are proposing a new study on this that would be run through the Global Environment Fund. If you're interested in being involved in the early discussion, I would be delighted to hear from you, so please do message and reach out. So finally, back to, I think, the biggest lesson I learned about this whole project is there's not enough money for all of the wish list of this project to happen, and that's what's holding things up. Banks and financial institutions will no longer fund anything, the wording is, that will extend the life of a coal plant. It's only available for either closing that plant or repurposing it. So, and on paper that sounds good. You're closing the coal plants, therefore renewable will take over. But as we know, that's not how it's going to work, because until renewables are dispatchable, people are going to continue to burn coal and gas. And in this case, these countries, it's only coal. They do have perhaps a phase out or phase down plan, but that's not for decades. And many of these plants in Asia we know are only 10, 20 years old. So they're not planning to cut down in the near future either. They're going to continue to operate until they get the money back on their investment for build and so on, and until they're not needed anymore, neither of which is happening soon. Many of them are in long-term contracts. They don't want to have a stranded asset issue. So they're going to continue to pollute at their current rate and may even increase their emissions, as we know from India, as they suddenly have to flex more than they did in the past. And so when you're asking plants to spend a lot of money on upgrading, then they're going to argue back, am I going to get this back? Is it worth it? Are you going to close my plant? Are you going to use my plant? I'm already spending a lot of money on keeping the lights on. Can I have a little bit of help with keeping the lights on a little bit more cleanly? Without investment, basically plants are locking in long-term dirty plants. An example of this, which I mentioned in the financial report, is Cirebon. Cirebon is one of the biggest plants in Indonesia, highest polluting, and the JETP program has decided that they will invest in replacing Cirebon brilliant plan. They're going to build wind and solar enough to cover its capacity and battery. So there will be a dispatchable replacement. However, that's not going to be ready for another 20 years. And in the meantime, I bet you Chiribon's going to argue that it doesn't need to put any control technologies in because it's on a closure path. You've then got 2 decades worth of mercury and other emissions happening until that plant goes down. So you've effectively locked in the highest emissions for another 20 years. So I would argue that in addition to closing, Chiribon still needs to talk about investment in retrofits for controls. So to conclude, we know that there are a lot of challenges for India. It's an almost perfect storm in terms of emission reduction, biomass co-firing, flexing and so on. And it wasn't until I was out there face to face with these people that I really understood that they are trying to do their best. They do have the expertise, but we're asking too much of them too fast. They're being asked to achieve in 1 decade what it has taken the Western world 3 or more decades to achieve. And they're being asked to do so with less water, with more challenging coals, and with no financial support. It's not an easy ask. If they invest in cleaning up their fleet, they may not be able to run that fleet long enough to get their investment back. Some are going to argue that's an excuse for derogation, and nobody wins in that situation. We all know that Asia is responsible for the greatest emissions because that's where the most coal is being burnt. But we must also accept that it's the region that's currently least capable of fixing this issue without international financial support. And as I say, that is addressed in a new short report that's coming out soon. So I've talked a lot. Thank you for your attention. If you're still with me, I will now have a look and see if there are any questions that you would like me to ask. I have one question from Jeff. What would be if I if I was given another project? What would I do? Well, with the seawater FGD one, I would want to know where that mercury is going. Just because you've caught it in an FGD system doesn't mean to say that you're not created a whole new water issue. So that. I also would prioritise training for emissions monitoring. They are desperate for training and emissions monitoring. They want to know what they're doing. They know they have issues, and they're willing to listen. If anyone wants to lead some training out there, I would welcome trying to set that up for you. Otherwise, the ultimate challenge is the finance. The funding isn't there, and they're being asked to do so much in a short period of time. We got to deal with SOx, and then we got to deal with NOx, and then we got to start thinking about mercury, and then we get to start thinking about biomass co-firing, and then, okay, we might have to start flexing now. This is all happening at once in India and Indonesia. This is too much for a coal plant. That is intrinsic to keeping the lights on in India and to the growth of their economy. So all I would say is a little bit of compassion, a little bit of empathy of the challenge over there. Understand they are trying their best. They just need a lot of help. And if anyone wants to work with me or put in touch with people over there to share expertise, I would be delighted to hear from you. That's it. That's all the questions. I'm going to close up now. Any other questions? I think there might be a technical question in the box that I'm going to defer to an email and get back to you in that because it's not a simple answer. So please email me and I'll get back to you on that one. Otherwise, thank you so much for your attention. As I say, all the information and more is on the website. If you cannot find it, just email me and I'll send you direct links. Thanks again. I really appreciate your time. Have a nice day.
Thank you, Lesley. Thank you so much. And all that's left for me to say is the slides from this webinar will be available to download from the webinar page of our website shortly. Thank you all for joining us today, and goodbye.